with the amount of guys that confirmed. But it looks like next time I'll ask an entrance fee because then the guys feel they have something to lose. Then they show up. Because I was worried we have about 20 spaces too little. but all right. So let's hope there's still some guys joining. I just want to say good morning to everyone. Thank you very much for joining us. We really appreciate it. It's our first event here at Vans Lab. So let's hope everything runs smoothly. I also want to welcome the live link. Good day, you guys. Thanks for joining in. I know there's a few of our bigger clients also joining in on the live link. So welcome, you guys. So just a few technical arrangements. If you guys need to go to the bathroom, you can see the window through there. So it's just in this door, turn right, and then right immediately again. And then please just be mindful of smoking. If anyone smokes, it is a lab. It does affect the analysis and stuff. So we have a dedicated area here at the back, at the Briar. Okay. I hope everyone got coffee and some rusks. I'm not going to eat all of this. I see there's still a lot left. So you guys must help me. All right. So just quickly, the program for today. Although we have two profs speaking with us today, it's not a lecture. Let's be interactive, ask questions if you do want to. At the live link, the link is interactive. You guys can ask questions as well. We have someone behind the laptop that will read out the question and we'll answer as we go. But let's keep it interactive. Let's have it a conversation. And Lindy, or first off, JP from Idwala is gonna just start the day for us in the right manner. Then Lindy will give us a quick, brief background on the lab. Then I'm gonna speak a bit of about the technology that we use within the lab. And then our big guest speaker that we flew in all the way from the Netherlands, Prof. Wim Bastiaanse, is there at the back. He's gonna talk to us about IRIWATCH and the latest technology regarding satellite imagery, and then Prof. Leon is gonna talk about the carbon. So that's a new buzzword in agriculture. Everyone's concentrating on the carbons and building up of carbons. So he's going to talk about the measurement, sequestration, and the trading of carbons on the international market. So then we're going to have a lunch. We're going to have a braai, and afterwards we're going to have a more open discussion. So you'll see on the invite that I sent, I said the way forward. If you have any questions for either Lindy, me, or the two profs, you're more than welcome to ask. But please corner them while we're eating or at the braai or whatever. Thank you very much, everyone. JP, if you can just start the day for us in the right way. Then Lindy will come up and speak a bit about lab.
Morning, everybody. From my side, welcome as well. It's really a privilege to be here. And I just want to tell something. I know Leon for, I think, 40 years now. We were just discussing it outside. And we were talking about, when we were students, we used to talk, listen, all the old toppies are standing there. Now we're the old toppies. But thank you. And something else I must really mention, I think it's going to be a very worthwhile program. I know a little bit of all the work Leon and his guys are doing here. It's really groundbreaking work, pioneering work. And as far as I know, has been read and discussed and experienced in the field. I don't know of anywhere in the world, really, and I'm not exaggerating, where people are working so much on soil physics. And so that's such a subject we've been neglected for so long in South Africa. But anyway, just on a lighter note, the other day, this Afrikaans English thing, I've got a good friend, and he wanted to buy a horse, and he goes to his neighbor. He said, I want to buy a horse. He said, but I can't sell you that horse. So why? See, but it doesn't look so good. But he insisted, they said, okay, but I want the horse. And 2 weeks later, they met again. He told his neighbor, he said, you bugger, you sell me a blind horse. He said, but I told you it doesn't look so good. But anyway, let's close our eyes and say thank you for being here. Thank you, our Heavenly Father, being here, saved us on the trip, on difficult roads, through terrible potholes, and all sorts of challenges. Thank you for being, having guests from overseas, well-experienced guys, well-knowledged. And thank you that we have the privilege to work in your garden. And please give us a responsibility to treat it as such. Thank you. Amen.
Morning, everyone. Hope everyone's doing well. We have some cold weather here today. It wasn't that we didn't plan it that way, so I hope everybody has their jackets. And if you need anything, just shout. Jennifer and Simari are there if you do need guidance to the bathrooms or need any assistance with anything. Okay. So I'm Lindy Smith. I'm the directing manager of Vans Lab and a chemical engineer. For those of you that don't know them yet, this is Prof. Leon van Rensburg, and he's a senior soil scientist and the founder of Vans Lab. And then we also have Roelof Smith, the marketing manager of Vans Lab. Okay, voicing the soil, listening to the land. That is Vans Lab's slogan. So we are here to assist farmers to help them gain their soil's optimum potential. So we have a fun activity next. Anybody that can decipher that word? I'll give you half a minute. We can put a beer on the table. Anybody want to try? Yes. First try. Well done. Okay, so accuracy, that's what we are all about. I just want to read the definition. The degree to which the result of a measurement, calculation, or specification conforms to the correct value or standard, compared with precision. Okay, a little bit more about us, about Vans Lab. So Vans Lab came out of a 15 years research project from the University of the Free State with Prof. Leon van Rensburg. And he discovered that there wasn't many labs that did the type of analysis that he needed for his experiments. And then we started with Vans Lab. So we have been up and running for 5.5 years now. And we are an independent laboratory with 18 employees. We have 3 soil scientists, 2 field teams, 2 GIS employees, and 5 laboratory assistants. Some of the soil analysis that we do is soil chemistry analysis. So we look at all your macronutrients, phosphates, pH of the soil, soil acidity, and then also micronutrients. And then soil physics that we do is a 3-fraction, bulk density, and sodium adsorption ratio. We also do fertility recommendations, which is independent, so we aren't linked to any fertilizer companies, but we do give you recommendations to places that you can get your fertilizers from. And then we also do physical recommendations and water analysis for irrigation purposes. We have different departments in Vans Lab, so that was just the laboratory part. We also have the EMI technology where we go out and do scans. We also help farmers with ultra precision farming, and then we also do spatial mapping with QGIS. We have a soil science department where our soil scientists look at recommendations. They do recommendations for farmers. They do product testing, and we also assist with environmental studies to help mines with rehabilitation. Then we also have the irrigation scheduling department, which is one of the main reasons why Vim is here today as well with IRRIWatch. Okay, Van's Lab also takes part in PT schemes, proficient testing schemes with AgriLoasa. We also have in-house accuracy measurements, and we're currently starting with our SANA's accreditation at the moment, so it takes quite a while. But this is all to ensure that we have accurate results, and we supply our clients with results that are accurate and precise. What makes Van's Lab different or unique? So we take core samples, which is an in situ sample or a genuine representation of the soil in the field. On these samples, we measure bulk density, saturation point, drained upper limits, and saturated hydraulic conductivity. And yes, this is commercially available to clients. So there is labs that does these types of analysis, but it's not commercially available to clients. So you'll wait a long time for your results. But here at Van's Lab, we do it in 2-3 weeks. Okay, who can take soil samples? So we usually send out our field teams. They can take samples for you guys. We do specialized sampling, zone sampling, grid sampling, and just normal sampling as well. You can also get your advisors to send in samples, or you yourself can take samples as well. If you take your own samples, just make sure that you are not contaminating the soil samples and that you take an accurate representation of the field that you want to analyze. Yes, to most people, it's just dirt. To the farmer, it's potential. To those who work in hectares and not hours, we thank you.
Great, thanks, Lindy. So now you guys have a bit of background on Van's Lab. It's not something that started yesterday. We've been coming for quite a while. So yeah, please speak to us. And if you guys need a new lab, we're on your front stoop here. We're close. You don't need to send them the samples to Brookside. Just for the LiveLink audience, I did receive some feedback. There's some glare on the screens. You guys can't see the slides very properly. I'm sorry for that. I will have all these slideshows on the website and then the video of the LiveLink as well. So you guys are more than welcome to go and look at the slides afterwards if you need to recap on something. Okay, so I'm just quickly going to sum up on the technology. I know a lot of you guys already know the technology, but there's the way everything links in. That's why we recap on that. So I'm going to go through the slides quite quickly. If you need to ask more in-depth questions, like I said, this is not a lecture, it's a discussion today. Please ask, and we can work from there. So this is just quickly our footprint, and the reason for this, I know the Western Cape guys, if you guys are joining us, you are the corporates for this. Normally, when you tell them, I know we're from Bloemfontein, they're like, oh, but you don't know the Western Cape soils. But with the 3 soil scientists we have, if you're, soos hulle sê in Afrikaans, jou sout werd is, then once you stand in the profile, you'll know that soil. So we work all across the whole of South Africa, and we concentrate on the soils first. Then we bring in the crop. All right, so we go out, look at the soils, and make sure that we get optimal circumstances for the soils and for the plants to operate efficiently. So, like Lindy also mentioned, accuracy, that's what we concentrate on. So just to give a quick explanation on this, if you look at the top left-hand side, you'll see if you go and shoot or you throw darts or whatever, if you're all over the board, you have a very low precision and a very low accuracy. But once you start getting that dots together, or you have your rifle sorted out, and he's shooting a nice group, you have very high precision. But that isn't to say you're hitting your mark yet. So that's where we come in with our calibration methods and everything to make sure we get accurate. We want to know what we work with. So when we talk about accurate farming, we're not downgrading or dismissing precision farming at all. It's actually a part of what we do. It's just we make sure that we hit the mark and we know we work with what we want to work with. So I haven't done this slideshow in quite a while, so it looks strange to me as well. Okay, so with this method, we can either be preventive or curative. So and the reason why I'm saying this as well is a lot of guys, when we talk to them, say, yes, but I already planted my orchard. How am I going to change anything now if I see I have to? There is ways. So we can do this preventive. So we can, if you want to establish a new orchard or a new development, it's very nice to do this and to make sure your planning is very accurate. Or if you already have established fields, to know that we can sort out the problems that have accumulated over years in that area. So if you already established, there's a lot of guys that think that this isn't then for them, but it is. It's through the bank for all types of farming activities or where you are in your process. Okay, so Van's Lab, we have a 6D approach. My dad has a very interesting saying that every fly has his heap, elke brommer het sy hoopie. And everyone just wants to concentrate on that. So if you get to the chemical guys, they're going to fix everything with chemicals. If you get to the fertilizer guys, they're going to fix everything with fertilizer. You understand what I mean? They just concentrate on their domain. We say, no, that's not right. You have to have a holistic approach. So we have a 6D approach. And we're not saying we're going to help you. We're going to try to help you, but we're going to be the experts in all 6 of those, let's call it, factors that you have to encounter or look at. But we go and in every place where we work, we pull in then the experts with regards to crop, with regards to irrigation, fertilizer, that works in that area. So we really extend and work with everyone within the area. So if we come and work with you, it's not I want to steal someone's clients. So that's why we work with a lot of service providers as well. Okay, so when I talk about a 6D approach, it's 6 drawers. That just imagine yourself a bedside drawer or your cupboard or whatever, 6 drawers that you have to open and really look into depth into each one of those to see what's going on. So the first one is your climate. And, well, we can feel the weather today. It's cold. Yesterday was hot, today it's cold. But when we talk about climate, it's over years. It comes with a long history. All right, so the first one is climate. We normally don't do that for farmers. You guys have been on the farms for quite a while. The crops are normally established within an area. So this is more when you come with new crops into areas and you really want to see if the climate's going to support that crop and you're going to have efficient production. So, but we do that for, like Lindy mentioned, our environmental studies and all that type of stuff. So farmers, normally that's a side, but we can do that for farmers as well. So the second one is topography. Another thing not very much people look at. So we are a soil lab and we tell you, listen here, second on the list, topography. You really have to look at that because that incorporates with soil and your management and all other aspects. So the second one, topography, and that's where we start. We really measure that in depth. So the systems that we use, you're more than welcome to afterwards look at them. They're at the back. We have up to a 4 centimeter in elevation accuracy. So we really look at topography in depth. Then we get to the soil. And when we get to the soil, we don't just concentrate on that top part. Normally the guys from fertilizer side, they concentrate on that top 150, 200 millimeters. We say no, you have to look at your whole profile. And just a quick example, in the Western Cape, when we got there, when we started working there, once again the Western Cape. Once we started working there, the guys, when we said, hey, listen here, we look at the whole profile, and that profile goes up to 1.5. They're like, oh no, I only farm in this top part. You're wasting your time and my money. And 95% of the problems that we occurred there was below the space they normally look at, and that kicked back every time. So we say, no, we really have to look at the whole profile, and we divide that profile in 3 layers. We have our, I'm calling it here your A, B, and C horizon, but it's not really your horizon because your C is going to be your parent material. I can actually call that layers, my A, B, and C layers. So the first layer is the top 300. That's where we concentrate on your fertilizers and all that stuff, your chemical part, and then your second layer is up to 750 millimeters, and then the third one goes up to 1.5 meters, and that's your production profile. And then the sixth one is where we were very glad when we yes, where's my English there? My airtime is already done. I haven't even started. Where we met Wim, and we were very excited about the technology that he uses, because Leon, like he said, he's been in the industry for a very long time, and for the first time, he feels like here's something we can use to really optimally manage our crops. And that's a moneymaker. That's at end of the day what everything is about anyway. So that's a moneymaker. You want to be optimal with that. So that's a 6D. So next time someone comes to the farm and tries to only sell you that top part, ask them, but how does that incorporate with what's going on deeper in? And how does that, in the end of the day, affect the plant? All right, so the technology that we use is the EM38. You will also see it there at the back. It's a very small, light machine, electromagnetic induction. Leon's been working with it for, like I said, 15 years within the varsity. We've been 5.5 years commercial now. So we really have a lot of experience on this. And in America, I had the comment this morning that it's being used internationally a lot. But through the research that we did, or I say that Leon did mostly, but I joined him the last last few years of his research. We really developed methods to look at more than what the EM is just invented or made for, and we'll get to that. But it's the EM38, and what really changed over the past 15 years, the EM technology stayed the same, maybe a coil more, you can get more depths, but what really changed is the GPS systems that you use with that. So in our research, we saw that using a cheap, inaccurate GPS that's 5, 10, maybe 15 meters accurate, you can't get the answers that you want, because I'm taking a reading here, and especially with salts, you know that can change within a few meters. So if I take a reading here, and tomorrow I want to come and take a sample, and I'm 10 or 15 meters away, I'm not going to get a very good answer or calibration on my data. Okay, so that's the GPSs. We really do not skimp on that. We invest a lot on our GPSs to make sure that the answers we can give you guys is really what we're working with. And that's what I said this morning as well, working towards that accuracy. So just the basic principle on the electromagnetic induction technology. If you have a stagnant magnet or a normal magnet, it doesn't have a lot of function. The wives put stuff up on the fridge with the magnets, or children play with it, or whatever. It's not a lot of functions that you can get out of that magnet. But if you have a coil and you put a stream through it, you generate an electromagnetic field. And that field you can manipulate. You can make it stronger or weaker to get bigger or smaller readings, and you can get data out of that reading. So that's the basic principle that we work on. And it's not something that I grabbed out of space here and now I want to come and push it down your throats. You work with it every day. It's just that we don't really think about it. And this is just a few examples that you guys see here on electromagnetic technology. So it isn't something that you're not familiar with. The most advanced example of this is your CAT scans. And what does a CAT scan do? It sends out that electromagnetic field into the tissue, and the machine picks up how that tissue gelei. Sien, daar's my Engels heeltemal klaar. Conducts. There you go. So that machine picks up how the tissue conducts that electromagnetic wave. So in the CAT scan, it just breaks up the tissue in very, very small layers, and it shows you how everything conducts, but it can never tell you what it is. So I can just go and delineate and see where something is that conducts differently. But a doctor still has to go and take a sample and analyze that for what is actually going on there. Is it cancer? Is it something that we don't have to worry about? But you still have to go and take a sample. And that's the big thing for me with the whole EM. There is 2 or 3 other companies in South Africa working with the EM as well, but they just scan, and then they want to come and give you your answers based on that. And you can't do that. And the reason for that is the EM is designed for 3 main things. That's water, salts, and your textures. So if you get a reading, which one of those 3 really influenced that reading that I'm getting, or what combination of the 3? So you see why I say you can't just go and scan and think, now I'm going to give you an answer. You really have to go and sample and analyze, what am I working with? Setting that scope, making sure I'm hitting my target. I'm not going to shoot that kudu miss very precisely. I'm setting my scope in. Okay, so how does it work? When you send out that electromagnetic wave, you can see there at the back is the transmitter. It transmits the signal. The soil influences that electromagnetic wave. It creates a secondary wave, and that wave is received back by the EM. And that's how we get our data. And this happens at a speed of 1,600 kilometers per second. So that's why we can move. You can see there at the back, we move with a quad bike over the field. You don't have to be stagnant. You don't have to stand still. I know with some of the older technology, that was one of the requirements, but you can move over a field. So we can very productively scan a field. Okay, so once that signal hits, or that magnetic wave hits a soil, what influences it? Okay, so it's conduction, like I said. So if you have soil particles, there where the soil particles connect or touch each other. Yes, see, rara. Maybe I should grab a beer here at the back, my tongue can loosen up. So there where the soils touch each other, that's where your stream will conduct. Okay, so think about a vase. If you take it, fill it up with tennis balls, and you take that same vase, you fill it up with marbles. With the marbles, you have a lot more connection areas than with the tennis balls. So that's the first thing, is your textures. The smaller the texture, the smaller the particles, the better the conduction. So sand, salt, and clay. That's one of the main things as well, what the EM is built for. And then if you have in your voids, your areas, your spaces between the particles, you have moisture there, or dilution, water. It also increases the conductivity. So you can pick up water very well with the EM as well. And then if you have salts in your dilution, it's also increases the conduction. So salts is witbrak, swartbrak, and of course your fertility as well. That's just the good salts, the salts that you want there, the plants use. So that's the 3 main things. And like I said earlier, with Leon's research, and there's some of his students here as well, I must give credit to them as well. He developed ways to get more out of the EM. Okay, so like I said, once you get a reading, it's up to 1.5 meters, 1.5 meters deep. That's the effective depth. You can go a bit deeper, but that's effective depth, and that was what the EM was made for. And you have that meter-long reading, and then about 500 millimeters. It's actually 750, but just to simplify, 500 millimeters on each side of it. So you have a 1.5 cubic meter reading if you take a sample with the EM. Okay, so let's just quickly compare this. And once again, I'm not degrading or dismissing anything that you do within the field. Anything that you do is better than nothing. But if you take this and compare it with a grid sampling, if you do grid sampling and you auger, you have that 75 millimeters 1 per hectare. So you have that 75 millimeters, that 150 or 200 deep, representing, how much is a hectare? 10,000 square meters. All right. So with the EM, once you start scanning with this, we have a transect on irrigation of 10 meters, dryland 20 meters. But let's work on the irrigation. You have 1.5 cubic meter reading every 40 square meters. So we take a reading every 3 to 4 meters, 10 meters apart. So it's 1 cubic meter reading every 40 square meters. And that's also why Lindy talked about precision, ultra precision way of measuring. And normally when I say this, the guys, sorry for my French now, oh, fuck, ek's nog eers op precisie nie. Nou wil jy al ultra precisie toe gaan. That's not the case. You can really use this data from the guy that farms your most primitive way of farming to the guy that does everything variable. You can use this data. Just a quick example, we had one client, he didn't have any variable application equipment or nothing. When we did this, he somewhere took 20-liter cans, marked out the zones that we had, and told his workers, listen here, this side of the drums, you do this application. If you're done, you come back, recalibrate, and then that side we do the other application. So really, don't get a big fright and say, oh, now I'm going to have to buy everything variable. That's not the case. We can really implement this throughout. Okay, so the practical side, so there's the EM38, and then it goes into a a plastic car at the back. So electromagnetic induction, remember if you have anything metal around it, that influences your readings that you get. So you'll see the plastic car there at the back. It's a certain distance behind the quad bike to make sure that that doesn't influence our readings. And it has to be a certain distance from the soil as well to get accurate readings. So there's the card, and then like you see there, the GPS. And that's, like I said, where the main changes came in, the accuracy of the GPS systems that we use. All right, so once we scan, you'll see this photo here at the bottom. If we do scan vineyards or orchards or whatever, we move that card to the right-hand side and we scan as close as possible, because that's where you're doing everything. You're putting your water down there, you're putting your fertilizer down there. That's where everything happens. So we make sure we scan where you work. It doesn't help you scan an interrow and it doesn't represent what's going on where the tree is. Okay, so on the right-hand picture, you'll see it looks like a lot of lines over the field, but if you go and zoom in, you'll see it's actually data points. And that's what I said, that's that every 3 to 4 meters we have a 1.5 cubic meter data point. All right, so there you see that 140 hectares where you would have had, let's say, okay, it's irrigation, 1 per hectare. If you would have had 140 samples, in this case, yes, I can't remember, I think you had more closer to like 40,000 readings over that whole area. So instead of 1 per 10,000 square meters, we had 1 for every 40 square meters. Okay, so you can really see what's going on in your field. That small little changes. We get to a lot of guys and then they say, oh, but is this thing going to pick up my my changes? Because, yeah, I have clays, there's sandy soils, and just a bit further you get loamy soils again, and it changes very quickly. But he's questioning me on this method, but he's happy with the 1 every hectare type of grid sampling method. So you can really get all that changes, and that's the food of the EM. It's that change. That's what really makes it pop out. Okay, so like I said, first of all, we start with the topography. We go and look at the, okay, sorry, so this was just quickly the technology and how it works, just to show you guys that it's not something unfamiliar. It's not something new that I want to push down your throats. It's not something I grab from space. It's out of this world. It's really something that we actually work with. It's just the way in which we work with it. Okay, so we start with the project. Once we scanned, we go and look at the whole surrounding area. So you will see the 2 farms here, the yellow lined and the red lined there, outlined. We have the 2 farms, but we go and look at what's the surroundings influences on that farm. Like Leon always said, you chose your wicket now, you have to cover it. Okay, so How is the outside going to influence my farm? And a lot of farms we were on in the past, we could show out a lot of the big problems just by the surrounding factors that the farmers never even considered. All right, so we look at the topography around the farm and how that influences the farm, and then we go and look at that up to 4 centimeter accurate data that we measured. So the second thing is the slope map. So how's that going to affect you, your operations, your plants, your water distribution, all that stuff. So that slope maps infield, your channel networks, where's the water going to accumulate if you do get a heavy rain shower, and where do you have to really go in and prepare for runoff of your fields or cover for runoff, whatever, and then your aspect map. So this comes in especially with the more intensive guys like your vineyards and stuff. Which cultivar do I plant on which aspect? I have a bit more cold units and heat units, and Lucas, I'm sure you will agree with me from Retondo Walnuts that had a big effect on their operations as well. So where do I plant which cultivar? Do I want something to be in production earlier or later, or I want to plan my operations. I don't want everything to be in production at the same time, because then there's a massive load of work or operations that needs to be done, and then for a while, and then you're quiet again. You want to spread that out and make sure you hit the markets on the right times, and make sure that your operations flows nicely and all of that. Okay, so that's also a very, very big thing to look at that a lot of people dismiss. Sorry, just thinking about it now. And the guy spoke French again, but I won't repeat him. We had a client in the Northern Cape that we scanned, and he never considered topography or the aspect as a big part in his production, and he produced maize, mealies. And he never got this reading beforehand. It's one of the service providers that we work with. He convinced him to do this, to do his, that guy installed drainage. So to do his drainage design better, he wanted this data. And when we represented this to him, he's like, my French word, that's where my production changes. There was like a straight line through the field. That's where my production changes, and I don't know why. And he didn't know what map that was. So the map just came up, and that was his first comment. And then we said, well, you never considered topography to be a factor in your production. And he was always overspending, over-investing in that area to get the production the same as the other side. And he would never succeed in that. Okay, so there alone, we could save him a lot of input costs. All right, so then we get to the soil, and I think that's where we want to be today. So that's spatial management of soil. So when the EM takes a reading, it takes it throughout the whole profile, okay, from top of the ground up to 1,500 millimeters. So that is your general card that you get, your EM card. So you'll see there is a red part, and that immediately draws your attention. All right, but if you go and zoom in, you can see there's a lot of spots and changes, even in those greener areas. And we really want to know what's going on there. Once again, the ultra precision, not knowing just per hectare. We want to know every square meter what's going on. So without ground truthing, like I said earlier, the doctor still has to go and take a sample. This card doesn't mean a lot. It gives you a good idea on the general conductivity, but what is it now? Remember I said it can be textures, it can be water, it can be salts, or it can be a combination of the three. All right, just quickly, another thing that influences this, if you have compaction, remember that soil is compressed. So it also has a lot more contact areas. So you're also going to get a higher reading. You see what I mean? You can't just go and scan and say, here's your answer. You really need to go and take samples. So what we do then, like I said, with the precision and accuracy, the EM is very precise. If I go and rescan that area in a year or 2 years and nothing big happened, the guy didn't change, had big changes, I'm going to get the same picture. But the readings that I get there in the legend, on the left-hand side, is relative. It's relative to the day, it's relative to the time of year, it's relative to sun floods. Remember electromagnetic induction, even your sun floods influences that reading. So that's why we have a certain calibration point, and we make sure that even year on year, we work with soil data. So I can go and scan that area again, and let's see there, the lowest is that 8.28 millisiemens. Next time I can get it 5 or 20. Like I said, that influence. So you can't just have a scan and a reading and interpret that to analysis. Okay, so what we do then is we go and determine sample points. So it depends on how big your area is. It's going to be 6, 8, 12, 20, and then from there on it depends on the hectares, but it depends on how big your area is. We're going to have sample points, and that sample points will represent your highest readings, your lowest readings, and everything in between. So we can get a good calibration model. We want to tell the EM, listen here, this is what a high reading means, this is what a low reading means, and everything in between. And then we, like I said, we build that calibration model, and then we go and calibrate that 40,000 or 50,000 data points that we have over the field. And we also tell you, let me ask you guys this first. Have you ever, with a grid sampling analysis, received any stats on the accuracy of that map? Just maybe a quick indication. You won't. First of all, you need, I think it's at least 140, Leon, help me, 140 samples just to get a good statistical model. So you'll never get stats with that. But if that guy comes and gives you that lines, you believe him, that line is that line. But what we do is I'm going to tell you how accurate is that line. Is that line really that line? If it's something simple, a dynamic property I'm managing, I'm going to work with that. But if it's something permanent and I have to go install drainage or divide my blocks or whatever, and my stats maybe isn't what I wanted it, I'm just going to go and confirm, is that line really that line? Okay, so what we get with and what we concentrate on is that physical properties that Lindy also mentioned. With that core sample that we take, you can see there the back is some of the sampling equipment, but that's what we really want to get to. So we concentrate heavily on the soil physics, okay, and the incorporation of soil physics with your soil fertility. So if you see that, I'm showing with a pointer here, as if that's going to show on yours. I don't think you will. So if you see that diagram, that circle, take that as 100%, that cake or whatever, it's 100%. Now this is an ideal representation. 50% will be solids, sand, salt, and clay, and your organic material. This isn't what it's going to look like in every field. I don't think we ever had a ideal soil before. So that's going to change. But that's what we look at. We look at what part of the volume that you're working with is actually soil, sand, salt, and clay, and what part is your pores. And then we go and look at the functionality of those pores. Because let's take this building, for instance. I have the bricks. That's my texture. But what I'm interested in is the structure. So if I go and put that bricks on a heap, what am I going to do with this? There's no functionality. There's maybe a few rats or insects or whatever that's going to live in there. But it doesn't have a lot of functionality. But once I go and I stack those bricks in an order, I create a kitchen and a living room and my bedroom and a bathroom. And each of those spaces have a different function. Now that's the same in the soil. So go and look at the solids, go and look at the pores or that spaces, and then we go and look at the functionality of those pores. So if you look at the blue part there, that's your bigger pores, your macro pores. So what's the function of those pores? Everything that needs to happen fast happens there. If you want to get water, if you irrigate and you want to get water down in your profile, that's where it's going to move. Air movement happens in those pores. Heat movement, CO2 exchange, all of that. That's everything that needs to happen fast happens in those pores. Then if you look at the green part there, that's your storage pores. So without that, we wouldn't have been able to farm. Water would have just ran through. So that's your smaller pores that holds the water back at a greater strength than what gravity pulls the water down with. All right, so, and that's what the plant used. That's your water available of, your water capacity or your tank. And then if you look at the red part, that's your really, really small pores. That's your clays that holds the water at a higher strength than what your plant can subtract it. But all your chemical exchanges, that's where that happens, that chemical exchange between the solids and the dilution. Because remember, plants can only take up what's in dilution. It can't get what's fixed to the soils. All right, so just once again, go and look at your bulk density. What's the importance of your bulk density? Can anyone just quick comment? What's the importance of bulk density on any operations? So if you go and you take a sample and you analyze for your fertilizer, your recommendations that you want to go put down, you get your analysis in milligram per kilogram. I have, let's say, P. I have 10 milligram per kilogram P. But what does that mean? That's a concentration. How many kilograms of soil do I actually have in that volume that I'm working with? All right, and what we found in the industry is that amount can be up to 30% out. All right, so if you are 30% out and you're saying you're doing precision farming, where are you? Okay, you understand what I mean? So you really need to know what's the volume or what's the amount of soil, the kilograms of soil that I'm working with in the volume that I have. So that top 300 millimeters. All right, so I can go and determine how much fertilizer do I need to put down. Once again, Western Cape. Yes, I'm referring a lot to them today. I haven't seen them in a while, so it looks like I'm missing them. They have a lot of stones in their soils. And that doesn't partake in the whole chemistry transactions and whatever needs to happen. Then they come back with a reading, a high concentration, milligrams per kilograms, and they're like, oh no, I'm fine. But once you go and recalculate that to the amount that you have in your soil, they're like, oh, what, is that all I have? So what we work with and why we measure this is, I want to tell you at the end of the day, listen here, your plant is going to use 20 kilograms per hectare of P, and you have 10 kilograms in your soil. Go and add what you need. Or you have 50 kilograms. Why do you want to add? Especially in years like these where fertilizers are so expensive. Why do you want to go and add something that you don't need? Oh, well, you need to have a buffer, but in years like this, we're not going to build that buffer. We're going to use that buffer that we build it over many years. Okay, so that's the importance of that. So if I come and I take a sample with an auger, I break up my whole structure. My whole structure is loose, and the bulk density isn't the same anymore. Once again, that's why we take the core samples. All right, so once we measured all that, we go and spatially represent this with the maps. And that's where the GIS office comes in. We spatially represent this to the farmer or to the client and say, listen here, this is what it looks like spatially. This part of the field, I will have some problems, this side maybe not. And you can see, is that screen going to stand? Okay. You can see in the left-hand corner up there, there's a green mark there. That doesn't mean I don't have a problem with that. You need to go and look at the legend for that. But that just says, hey, listen here, my stats is great. Okay, so the stats I have for that specific analysis is very good, and we can use that map. If the stats wasn't as good, I would have had an orange mark there and say, listen here, if I need to go and do something permanent, let's just go and determine, is that line that line? Or if it's something dynamic, like fertilizer, I'm not going to waste my time, I'm going to use that. or sometimes you'll get a red cross there. And that says, listen here, the stats wasn't good. We're not going to use this map. Let's go and look at why this map isn't good. So let's say, for instance, once again, let's stick with P. I have my analysis over that field because with all this variable application and all this big hype around your fertilizer and optimizing fertilizer, a lot of guys have really sorted out their main problems in terms of fertilizer. So you'll get to a field and I'll have a uniform P reading over that field. But now my EM gave me a high reading, it gave me a low reading, and everything in between. But it can't connect with a statistical model, a high reading with a high analysis and a low reading with a low analysis. So that's why I'm saying, then you can't get any stats. Then we go and look at, listen here, what was the problem, or why didn't we have stats? No, it's uniform. I don't need to worry about that. It's easy to manage over my field. All right. So, sorry, that's for your physical properties then. You'll see we talk about hydrophysical properties, everything that's connected with water. The silt plus clay, bulk density, your KSAT, saturation point, drained up limit, and your plant available water capacity. That's everything that we analyzed with that core samples. And you're going to get maps like this for every element. Then we also go and look at your salts, like I said, and that's also another tier point in the industry. A lot of service providers wants to go and look at especially your sodicity, Swartbrak, in terms or with the chemical analysis, and you can't analyze for Swartbrak or sodicity with that type of analysis. There's a special analysis that you need to do for it, and you guys are also welcome afterwards to walk through the lab if you guys want to, and we can show you a bit more on where we do those analysis. But there's an international standard at which you have to measure that, and unfortunately the industry wants to do everything as cheap as possible. Oh well, it's understandable for the farmers as well. It's very high input costs, but you can't, and that's what makes the EM a very nice option, because you have a lot of data points, a lot less samples that you would have had with your grid sampling method, but you can do quality analysis and you can do the right analysis to analyze for specific stuff. Like I said now, your salts, your sodicity. You can't just get that out of a fertility analysis. A lot of guys, when we get to them and say, hey, listen here, this is what your sodicity looks like where did this come from? My service provider never told me this. And you can't see it on that normal fertility analysis. All right, but salts, so sodicity is really the guy that buggers up your structure. So what that does, it causes your clay particles to disperse. It goes into suspension, and it washes into those pores and it blocks those pores. So if you have a lot of dispersion, and that's one of the product testing stuff that Lindy spoke about, is Leon developed a method to really go and look at your level of dispersion in your soils at that stage in your field. What I said now with the sodicity, it's that really influences your structure. And once you have a soil that's dispersed to a level where you really have trouble with it, that soil is going to be as hard as a brick. You can't get water into it. You can't get the roots won't develop. So it's really a big problem. So you have to go and look at that and manage that before you get to a situation where you can't rectify your soil. That's what you see. Guys spring up pivots, and then 3, 4, 5 years later, they just move that pivot. So that's criminal. We say that's criminal. If you really want to take land away from someone, take it from someone like that. Okay, anyway, so that's the sodicity, and then the salinity is just a high concentration of salts that increases your osmotic potential. Am I saying it right? And that just holds water back at a greater strength than what plants can pull it. And remember now, plants can subtract water up to 15 bar. It's actually minus 15 bar, but just talking about the value as a 15 bar. But think about it, you're pumping your car's wheels at what, 2.2 bar? And plants can subtract water at up to 15 bar. Okay, so that really holds, that salts, it creates a water shell around it, and that whole drop becomes too fat to move into the roots. So the roots can't get access to that water, it can't get into the plant, and you're going to get a plant showing you symptoms of drought in a wet soil. Okay, so that is easy to manage. It's normally you must just have sufficient drainage in your profile. If you don't, you need to install artificial drainage, but you can wash that out. But your sodicity, you're going to buy that farm again with everything you have to do to rectify that soil. And then we go and look at all those physical properties for your second layer as well. So everything that I mentioned now for the top layer, we do that for the second layer as well, and we go and look at that for the third layer as well. Okay, so we break up your profile in those 3 layers, and we really can go and see then, where is my problem? Where in my profile am I experiencing problems that reflects on my plant? And then we also do an integrated measurement for the whole profile. Okay, so the aim of the project at the end of the day, you need to get something back. If this method can't put money back in your pocket, why do it? If it can't increase your efficiency, if it can't simplify your operations, why do it all then? Okay, so the aim of the project at the end is then to get management zones based on permanent properties. That's never going to change in your lifetime or your children's lifetime or their children's lifetime. Okay, we want to base our management zones on permanent properties and not what the industry does at this moment, the dynamic properties. So you go, you do a variety map on your soil fertility. Next year you come and sample again and it looks different again. You're creating your own variety in that soil. So we know plants are going to react more or less the same within that zone because of your permanent properties, and we manage them according to that. So your permanent properties I'm referring to will differ from case to case. We don't have a generic approach. We really go and look at what happens on each project. We have a project-based approach and not a generic approach. So what permanent properties is going to be the main influences on your operations? So we can look at your depth to your permeable layer, in other words, your soil profile depth, your textures, which I said has a very big effect on that whole circle that I showed you guys, your topography, and then in some cases, dynamic properties plays a big role. So let's say, for instance, salts. You have a high concentration of salts, and that influences the plant more than what your permanent properties does. And we concentrate then first on rectifying that dynamic property and making sure that that doesn't have the biggest influence, and then we work afterwards with your permanent properties. So we will take a client, we had a client like that can't remember where now. He had a huge concentration of salts. So we did this whole project for him and said, listen here, here's your management zones, and this is what you're going to operate according to, and that's what you're going to give you your biggest potential. But let's go first and rectify our salt problem. And we put that aside just for now, and for the next 3-4 years, we concentrate on the salt problem. Afterwards, we're going back to making sure we work on the permanent zones. And then you'll get a map like this, incorporating all those permanent properties. Like I said, what's the main influences on your production unit. And then we'll get a map like this saying, listen here, relative to my farm, here's my high potential areas, here's my low potential areas. And then that really depends on the farmer then. How am I going to incorporate that into my production? Let's say, for instance, dryland farming. If I know I have a piece of my field with a very high potential of soil storage, or water storage, I know I can push up my planting rate there. Because if I take into consideration what the weather forecasts are for the year, and I know they are quite right, and I can follow them, and I'm going to have a lot of rain or not. Either way, I can increase my planting rates there, or decrease my planting rates on areas that's not going to be able to sustain a 50 kilogram or 100 kilogram planting rate per hectare. Okay, so you can really go and incorporate that. And then I'm jumping ahead a bit now, but that's what we liked with Iriwatch a lot. Then we can go and follow, listen here, but where am I in terms of my soil capacity? And if I then have to go and put a top dressing down, am I going to create problems for myself? Not having a lot of water, just stimulating a lot of growth, and I get a lot of plant growth, and when the plant needs to really produce the crop that you're going to harvest, it runs out of water, or it grew itself out of its hulpbronne. Okay, you understand what I mean? So with this technology, we can really incorporate this. And if I say this now, I mean the technology that we use, what Wim is going to talk about, and what Leon's going to talk about. We can really incorporate this for any type of farming production: dry land, irrigated, floodlands, any type of production units. But that's what we get to, and then we can say, listen here, okay, let's go and manage optimally now, not over invest where I'm not going to get my return on investment, and not underinvest where I can make a lot more yield or get a lot more production. I think that's normally where my soil talk stops, and then Wim is going to take over what I normally speak about then after that. So I have an Iriwatch presentation here if you want someone to carry on this one. No, I'm joking. Is there any questions? Like I said, I really just explained the technology quickly. You guys can afterwards come and ask again if you want some more information. I'm going to say it now because that's normally the first question is pricing. Come and talk to me. Like everything in agriculture, it depends on your hectares. But other than that, any questions? Someone? I know a lot of you guys know the technology a bit by now. You have worked with it. But other than that, nothing. Okay, so ons ouens gebruik QGIS om daai verwerkings te doen en alles. En dan is daar ook 'n paar programme wat Lindy self geskryf het om ook die data te verwerk en te hanteer en so. Bertus, maybe you can just make that comment again on that you did for the LiveLink guys as well.
Thanks, Roelof. I have to switch to English also, so it might be interesting. But I think it's important from an industry perspective that currently most people is looking at a chemical side, but I think your soil physical side and that is probably more important going forward. So I think it's a holistic approach. And I like what you're doing because you're looking holistically at where's the real issues, what is the permanent things. And I think maybe something that I haven't mentioned that's important to me also, I think we concentrated on variable application. I think we should change that a little bit. Try to get your soil which you're farming on as homogeneous as possible so that you can manage it easier. I think that's probably a better approach than try to manage the differences in the soil. So if it's places where you can manage the same, get your organic matter content properly, and then you can manage that properly, I think that's important. But I think this together with what Prof Wim is going to talk about will be game-changing in the industry in terms of managing your soil. I think specifically Prof Wim a little bit later, and I've actually introduced him, so I really like what Prof Wim is doing, is having a virtual soil moisture probe, even on a dry land basis, and I think that is also game-changing.
We had another Farmers Day at Vierfontein, and when I started talking about topography, the one guy immediately shot up his hand, and when I asked him, he said, listen here, lad, this area is flat. This whole world is flat. Topography doesn't play a role here. And in the same breath, he talks about his versuiping. Okay? And then I told him, but topography plays a bigger role here than in the Western Cape, where it's hilly. Because now, in years like that, where you have a lot of rainfall, where do you go with that water? How do you get that water? You have to work much more precisely to manage water on that flat area than guys working on hilly areas. So each area has its own uitdagings. Yes. I must get to more clients. Thanks a lot, Bertus. And JP, sorry, we rudely interrupted you.
Yes, no, I just want to say, we had two places where we used EMI. One was in Kroonstad, the other in Bothaville. As a matter of fact, we investigated the so-called subsoil acidity, which is a big problem. As you all know, we are now suffering in South Africa. There are estimated 500,000 hectares of subsoil irrigation acidification in the Northwest Free State, and it's very difficult to solve that. So we investigated some, and we even apply with the aid of a company called Rula, very sophisticated apparatus, 1.5, 2, even up to 4.5 tons of lime in the subsoil. But the results were actually disrupted by the water table because just of the reason you just mentioned. The water table soils contains a lot of salts, nitrates, and it's also been confirmed by the SOK, which is the Sandstone Ontwikkelingskomitee, and Dr. Andre Nel and Dr. Donnie Bekes. And there's a huge problem because now we're actually sitting in some places in the Northwest with a double whammy, because you get a good soil up there, and just below the acid, and just below it is acidicity problem, very high sodium. So with the aid of this technology, you're able to detect those things.
Thank you very much, JP. Thanks, Bertus. And then Rihantu.
Yeah, I just want to comment on your what you talked about, the topography, and the importance of doing it even on level land. And when you look at the surface, and it might be level, yes. When you go subsurface, the subsoil is not, might not be like that. And using the EM, it brings that out, and you can profile that.
Over to the two profs, but let's start with Prof Wim, all the way from the Netherlands.
Dankjewel, Roelof. Goedemorgen allemaal, boeren van Zuid-Afrika. I'm very happy to be here, and also because of the title. So, everything is about the title. So, Roelof spoke about the soils, and I'm listening to the crop. I'm listening also to the land. That's one of the slogans. But I'm listening to the crop. So my talk is about how we can use satellites to really look at what crops are doing. Yeah.
Can we move down a bit?
Yeah. No, but I like it. Okay, anyway. That's okay. That's fine. Yeah, sure. Yeah. And although I'm a prof, I grew up on the boerderij. So my father had aardappel. So after 25 or 30 years in academia, in university, I thought, let me stop with this. And let me make something that people can use. See, I have 20,000 citations of all my scientific papers all over the world, but it's very boring, and I really like it to bring the technology to the boer. So that's why I'm here. And one other thing that helps, I studied soil physics, so I understand Leon, which is good, because we are partners. And so I will be here the whole day. So, please interrupt me if I say a new thing or something not clear. But I will be around the whole afternoon, so there's any always a moment to get more clarifications. So let me first introduce you ERIWatch, and then I will go through the technology. ERIWatch is a relatively young company. I have also to read what's there. So I started only a few years ago, and we are now covering 1.2 million hectares. So this morning I gave irrigation advice to 1.2 million hectares, okay, in more than 60 countries. So we are really operational. We have turned the science into something operational. Irrigation planning is for us very important. So I will speak about irrigation planning. I like satellites. You know, satellites don't lie. If I go to somebody who says, is your soil wet or dry? Then one person will even say it's very wet. You know why? Because he's looking at the tracks of the tractor, of the John Deere, and then the soil is compacted and there is water in that track. Yes, of course, there shouldn't be, especially on the tail end of a furrow, there should be water. But then in the meantime, the land is very dry. And so it's not so easy, and that's why I like to use satellites. Satellites come every day. Every day. And actually, one already came. I don't know whether you've seen it, but it just passed. So another one is coming at 5 minutes past 1. It's measuring your temperatures. Temperatures and everything is measured by 10 by 10 meter. Okay? But we just have to learn on how to use it. And I will speak a lot about temperature today. So it's real time, and you have to take a data subscription. Now, if you want a data subscription, you have to go to Roelof. Okay, he is my partner. So this is what we do. We have satellites. We also look at weather predictions. So we look at the future. What will be the weather for the next 8 days? I don't like to go beyond 8 days. I don't trust. Maybe 8 days is already optimistic. Huh? And then also I put here local in situ measurements. And so in wet countries, they like to give me your own rain gauge. So if you have invested in your own rain gauge, we can read your gauge, for instance. Huh? Or you have a weather station, we can read it. But what we are really moving towards with VansLab is that their soil scans and their permanent zones that Roelof spoke about, we can also read. You know, so we can really read the soil properties also into ERIWatch. And then we have our secret model. That's my business. So I've been working for 35 years on a model. And then we get an app and a web data where you can show and look at many things. So these are all the countries that we have been active. We are active now. So I'm traveling a lot these days, as you can imagine. And these are the places where we are currently active in South Africa. So the majority is from VansLab, but also a few other international partners that we are working with. And then also you can see many fields in West Cape. This is today. So probably when the next season starts, we will get more fields getting in. We are a small company of 7 people. Basically, we are a family company. So if I really want to scale up in this very big world, I need partners, okay? So we call them resellers. I think Roelof had a different name for it, but we call them resellers. So I started in 2020 with all kind of people that I know from my past. And now we are 2 years later, and the good news is half of them left. That's good, you know, because the right ones remain. They are the ones that are motivated. These are the ones that have vision. And also, if you move from classical measurements of moisture in your field to a satellite, it's a mental change. And many people don't do that immediately. You know, you need to be an innovator to really say, okay, now I believe the satellites. And so things go slowly. That means what I wanted to say is that if you really want to start promoting remote sensing and satellite measurements as a truth, not only it has to be accurate and precise and so on, but also it takes time. It is a matter of years. You cannot introduce this satellite technology just in a few years among farmers in South Africa or in Zimbabwe or wherever. You know, it takes a longer time. The good news is I have now a very nice group of people that help me every day. So, what can you do with EriWatch? And I'm making a very big jump. Usually I put this slide at the end. I go first to all the technologies and results, and then people are like, yeah, what am I doing here? You know, so I thought, let me start this up front. You know, what can you do? And one very important thing is irrigation planning, and I will give you some examples later on why that is possible. So we give you an irrigation advice for every 10 meters before the breakfast. Now, what time is your breakfast? What time you take the breakfast? Somebody before 5? Yeah? No? Okay, then I'm on time, because at 5 o'clock your data is in your mailbox. Okay? Also the monitoring, which means like, okay, but let's learn from my irrigation, you know, like how much did I irrigate? And how is my yield response? How does it compare to my soils and so on? And, you know, we work a lot in California. And in California, if you steal one drop of water from the canal, a lawyer comes. You know, everything is lawyer here, lawyer there. So California has a big problem, as you know. There's a big drought. But they have money and they have a law. Okay, so groundwater pumping by 2040, the year 2040, is only marginally possible. And they make it very clear to the whole community, this is the future amount of groundwater that you can pump. And this is a schedule. We are now here, we have to go to 2040, and year by year it has to go down. Okay, and you know, this is very interesting. They want to monitor on how much groundwater is pumped. Okay, normally you would say, okay, I'm going to use my flow meters. You know, I have already flow meters. Many of you, who has flow meters on the farm for measuring irrigation? Can you raise your hand if you have flow meters? Nobody is measuring its flow? Nobody? Oh, that's interesting. Yeah, okay, that makes sense. In California, all have a flow meter, you know. And you know what the government is saying? We are not going to use it because too many manipulations going on. We trust the satellite remote sensing from EriWatch more. So our data is used to really also see whether everybody is going into a more sustainable way of agriculture. Number 2. Number 3 is more crop health. You know, like, is your crop growing well? And I will very soon explain how we do that, how we can say something about your crop health. But also the stresses, like environmental stress. We are always worried about water and water stress. But in fact, heat can be equally important. See, in Europe, we had a very hot summer. You know, we have even in the Netherlands 40 degrees air temperature, surface temperature 50 degrees. See, our potatoes didn't like. We have the wrong varieties. You know, so heat stress, and I tell you also stress because of dry air is very important. Your crops don't like low humidity, low air humidities. They don't like. See, then they evaporate too much. They don't like. They will stop shutting the stomates, the huidmondjes. Huidmondjes gaan dicht. You know, and then actually the crop is not growing well. So stress is very important. What else you can use EriWatch? Forecast. So when we are midway in the season, we start to forecast how many tons of milli is the word, huh? Corn? Milli. How many maize you can harvest, or onions, or bananas, sugarcane. We also look at precision agriculture, of course. It's a day of precision agriculture. So especially if it's a soil scan. So it's such a nice complementary analysis that you know everything about your soils, the slopes, the aspects, you know, and the chemical composition, the physical, and then relate that to your growth independently. See, if you have crop growth models, what they do, they need the soil as an input, and then you simulate a certain crop growth, but it depends on the soil inputs. EriWatch is doing it independently, completely independently of the soil. We will calculate the crop production. I will show you in a minute. So that's interesting. Nitrogen. So my sugarcane clients, they all come to me now and say, can we give less nitrogen? Yeah, maybe, but maybe not. So we have developed nitrogen reference curves. How much nitrogen should be in your crop during the season? And if it's too low, you can give extra. But if you are too high, or actually you're spoiling money. So that is a very direct application. Insurance. Bertus is here. So I have a few slides that also we can help the agricultural insurance. You know, like how much is really the damage. Sustainability, yes, that's something that comes also more and more. Because everyone claims to be green. I have a very green product. My product is very environmental friendly. Buy the coffee from brand X because we grow coffee sustainably. Who knows? They all make claims, you know, and big nonsense stories. So we can now just check them out. And the last one is also interesting. And I'm not sure I should even say that here, but maybe some of you are a big supporter of field equipment and soil moisture sensors and weather stations. But what I see happening internationally is more and more organizations go what they call sensorless. They want to replace, you know, the soil moisture probes by something else, by satellites. So I'm doing this for 35 years. So when I was speaking 35 years and I was saying, hey, you can have your soil moisture from satellites, they were laughing at me, you know, like, are you completely crazy, you know? But now it's changing. Now people accept it. They know that, you know, there is a lot of scientific progress and research done, so that is all good. So what EriWatch is doing is essentially measuring the temperature of the canopy, the blood temperature. And why? Because actually showing whether you are okay. Same with your health. If your temperature goes up, something is wrong. And you have to go to a doctor and do a scan. So basically, by measuring the temperature of the leaves, we can also see what is going on. And it has a lot of impact. It has impact on the radiation physics. We have not only sunshine, but we have also long-wave radiation for our crops. Long-wave radiation depends on temperature to the power 4. So it's highly non-linear, very important. But also it controls the transpiration, the sap flow. If a plant is cool, it has more sap flow, for sure. 100% sure. It's all physics. At the same time, we also know it has more photosynthesis. That's what we want, right? We want more cane. We want more potatoes. And we want more carrots, whatever. Grass, if you're a dairy farmer, you want more feed. You know, physics is the same. So think about, I'm always explaining this to my students, you know, like, what happens if you sweat? You know, you really, by sweating, your temperature goes down. So this is a person that's getting hot and he starts sweating and his temperature is going down by 2 or 3 degrees. So sweating is good, but leaves do the same. We have hot leaves, we have cold leaves, and you can say in general that, you know, when you see a cold leaf, it is sweating. So that is a fact. That's physics, biophysics. So that's why we are so keen to measure the temperature of the leaves. And this is an example. So here, I don't know whether you can see on the screen, but we have here these pixels of 10 meter by 10 meter. And these are very small fields, even fields of half a hectare. So these are small holder farms, in this case in India. But we make these maps every day for South Africa. So if you really want to know what happens inside your crops, inside your orchards, inside your citrus, then really measure the temperatures. And actually we make corrections for the slope and for the elevation. So if you have differences in elevation, we even make small corrections that we say, look, all the variability of the temperature we can relate to transpiration and to photosynthesis. So that is a very important one. And you can see it here. You see between 16 to 30 degrees. Can you see it? Is the screen clear enough? Yeah. So who is irrigating? Who is irrigating at this moment? And number 2, what's his name? Well, we don't know the names, but all the blue ones are irrigating. Huh? That's very clear. So they're just irrigating, and because of that, the moisture is high, and they have 16, 17 degrees. The ones that really have no land or barren land, they are at 27 degrees, 28 degrees. And here is a map that shows on the left-hand side the temperature, but on the right-hand side an NDVI. An NDVI is a vegetation index. I'm bringing this up because some of you may have heard about NDVI. Okay, an NDVI is a vegetation index. It will tell you how green your field is. Doesn't say, whether it's healthy or not, or is how much ET or moisture, or, it's just like, I always say it's like a smiley. If your NDVI is high, it means something is good. But, if it's low, you don't know what's going on. And there is another very important thing. If there is a problem with your crop, whether it has a disease or something else, a hailstorm or a drought, before the NDVI, the vegetation index, go down in time, it will be another 10 or 14 days. It's too late. If you have a disease, you want to act. You want to act immediately. Now, the temperatures, actually, that's almost a delay time of seconds. If there's a problem with your crop, immediately the temperature changes. When you measure the temperature of the crop, then you see it's changing with the wind speed. So if there is a little bit more wind, immediately it goes down. If the wind goes up, temperature goes, so it's changing immediately. So temperature is good. And probably the image is not, clear enough to see, but if you look at the patterns, I think the temperature pattern on the left hand really shows much more variability. So you can learn more from it. So if somebody is talking to you like, oh, we are going to use remote sensing and NDVI, then think about that. That is the old technology. The technology from 1969. Okay. So do you want to use a telephone from 1969? No way. So don't use NDVI, for your crops. Use temperatures. So here are different thermal satellites. I will not discuss in detail. But what is very interesting is that there is now so much demand from agriculture worldwide that private companies start to launch their own satellites. It's a new development, So again, 20 years ago, I was preaching and I was like, I was the only one. Now, new satellites are coming to help agriculture, which is good, So this is a theoretical picture. I'm not going to explain, don't worry. But what we do is we look at how much. Okay, this is another thing. Solar radiation. Solar radiation is measured every 15 minutes for South Africa. And it's for free. And it is so accurate. You cannot even measure it more accurately in the field. So we know the solar radiation, we know the solar position, we know how much energy, and then what we really do is we look at the temperature, and then from the temperature we say how much ET there is. ET is evapotranspiration. Verdamping, is that an Afrikaanse word? Yeah, verdamping. This is all about verdamping. You know, so if the temperature goes down, your verdamping goes up. So you can see on the irrigated land, you have a high ET, hoge verdamping, and a low temperature. And then the other one is a fallow field, low ET, high temperature. So that's what we do. So basically, I can tell you exactly how much water is being used on every field, on every 10 by 10 meter yesterday. I don't need to know your type of crop. I don't need to know the age of the trees. I don't need to know your root depth. I don't not even know the soil type, because I solve the ET from the other components. So that makes life easier. That you can do things. So we also want to understand what happens in the root zone, because we want to irrigate, or you have a rain-fed system. You want to know, is there enough water in my root zone or not? So we make also water balances. So we make water balances of root zones. So we have the ET, we have the precip from field measurements, we have the depths of the roots. So we also make estimates of the dynamic growth of roots. And we look at soil moisture and soil moisture storage. So basically, we model the water balance. This is also needed for days that we have no images. And on days with clouds, we have a problem with the images. So we have many images, but if it's clouded, then basically they are useless. That's a fact, okay? So clouds are my biggest enemy. But I have the water balance. So even if there is a cloud, I can still run my water balance. I take the ET from yesterday. I take the water storage from yesterday. I have my rainfall from stations, or if there is no stations, we have a global model for that. So anyway, we can always make the water balance. I just want to show that for people that do not know us, that we have been working in science very actively, maybe too long. So then, it's about, okay, can you then predict my crop yield? So these are all green beans in France and Hungary of one client. And every line is one field. So we measure for every day how much crop is produced. Okay? That is what we call the dry matter production. If the crop is very low, you cannot say about yield because there is not even a grain. But you can say, okay, I know what is the total dry matter because I have a stem, I have a leaf, I have a root. So then for every bundle of every line of the bundle, we know that what is good and what is bad. So if you're really at the top end of the curve, then for 100% sure that you will have the highest yield. So this is the first thing. So for instance, if we want to compare whether you're doing well with your milli, and you want to compare all the milli fields in Free State or in Eastern Cape, you can say, okay, plot all the milli fields in Eastern Cape, and you can really see what the distribution is and who is good and who's bad. But of course, you don't want to know about your dry matter. You want to know your cash. How much am I going to harvest? So actually, that is here on this particular slide, that the second part of your life cycle, you get the one with the lines in it called yield. So that's where your yield is coming of your milli. So since we know exactly on which days there was production, we really have it from. Remember, we have it from emergence of crop to harvest. So we also know exactly then, but in this period we get the formation of tasseling, and grain formation, then also you can start calculate how much yield is there. So we do that. We do that together with our clients. And this is an example of aardappel in Holland, in Netherlands. So here every dot was one field, so it was a big one. It was a big farmer, and so basically we could really predict his total amount of potatoes very well. So we could exactly say that how much ton he was going to harvest. And although you can see from field to field, there is always some variability. That is also a fact. Not every field is 100% accurate. That I have to confess. That is true. That's just a simple fact. But overall, it really works nice. So think about whether crop production is important for you. You can say, look, I know it anyway, because after my harvest, I know exactly how much I have grown. But it's maybe also interesting to look inside your fields. Are there places that are doing better than other places? And that's exactly where the soils come back. Because maybe if you have certain places within the field that are really doing well, that is maybe related to this water holding capacity, or you have more organic matter, or your pH is more optimum, and so on. And then also you can learn. You can even learn your own fields, like, hey, maybe I should give more focus here or more focus there. So very important, and this is one of these validation graphs. Yeah, just again for people that didn't get the message yet. So, this is sugar beet, and on the right-hand side of the picture, the beets were cold, and on the left-hand side, the beets were hot. So we can really measure the temperature. And then you see the guy here with the size of the beets. So you can really see that when your crop is cold, you also have bigger beets. That's the story. So very important that we can use thermal remote sensing from satellites to measure your crop production. So we have a lot of outputs. I'm not going to discuss. We have different packages. We have a dryland packages for dryland farmers here. So if you're doubting, should I go for another round of fertilizer or not, you want to know, is there enough moisture in the soil? Because otherwise it will not get into solution and it will not be helpful. So we have a dryland package with only a few parameters. We have a premium package that actually 98% of farmers are using. And then in addition also we have climate smart. And this is more because governments are going to ask for it, like, hey, but what is the contribution of agriculture to climate and so on. So, yeah, that is the one. We are also working on some new products. So I already mentioned a few, and but yeah, we are continuously developing products. I think you do not want to know about all the equations and physics, but you want to know what you can do about it. And let me pick out today the one here on precision ag. So if we have this variability of the soil, and if we know from the last couple of years what the production was from the satellite, you can combine that information. So you know exactly which pockets are good and which pockets are not so good. So what do you do with your expensive Syngenta seeds or Bayer seeds? Are you going to put everywhere the same amount of seeds, or are you going to put more seeds per hectare on the places that are good? That's the question. You can have a uniform application, but we know from the last 5 years and the soil scans that it's not very likely that your yield will be uniform. Actually, we know it will not be uniform. So why should you not put more seeds per hectare on those fields with a higher loam content, lower temperature, and high production that we know from the last couple of years? That is very you get more cash per hectare. So, but also with the fertilization, if you know that the impact of the fertilization is not as high as you would have desired, you can also maybe put less fertilizers on very sandy pockets. People always say, oh, it's not growing well there, it's maybe sandy, I put more fertilizer. Yeah, but it will not change. It will remain low. Production will not suddenly go up because the production is limited by something else, not by the fertilizer. And also same for irrigation. So if water is scarce, and I know water is scarce, and especially scarce in the arid parts of South Africa, then really you want to bring only the water where it's really needed. So therefore we have that irrigation planner. This is how it looks like, and I've taken just one Henko. Is Henko here? Henko Agri? There's a client of you? No? Yeah? No? Oh, you know him? Yeah, okay. Yeah. I just found him in our system. I don't know exactly. Yeah. So, no, just checking he's in the room. But see, here you can see the dates. So you can see the bars with the different dates. And so actually there is one gray bar that's saying today, I think. Yeah.
On the live stream, just answered me now. Now I'm watching remotely. So he's on the live stream.
Yeah. Oh, he's on the live stream. Ah, very good. Thank you so much. So, okay, great. So this is your advice, sir. Today you have to irrigate. Also the next days you have to irrigate. And if you want to know the amount that you should irrigate on, this is only one particular field, you have to click on the blue bars. So, yeah, I'm not going live today, but there is this. In the graphs, you can click on irrigation planner. That's what he should do. So Mr. Henko should click on the irrigation planner, and then he should click on the blue bar, and it will tell him how many millimeter he should irrigate, field by field. And actually, there is then the moisture goes up. So the moisture, if you do not irrigate, it is the dashed line in blue. It will go down, 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 down. And if it enters in the red zone, you will get water stress, so his crop will be impacted. He should stay away from that red line, because that red line is your stress line. Okay? If he's irrigating according to this advice, then the line will become green and dashed. You see, and it's going a little bit up and down, but then it's perfect. His crop will be happy. Then, because I think he has two pivots, he can also decide to irrigate not everywhere the same amount. So here, actually, you can see that in the middle part, he should go for the maximum amount. But for some reasons, on some of the edges mainly, there is sufficient moisture. And now I know with a pivot that's very hard to control. But in case you would have had a drip system with sectors, you can really say, okay, this sector I give, for instance, only 3 hours of water. The other sector, I give 6 hours or 5 hours of water. And very funny, I have to share this experience. Because people talking about variable rate irrigation, maybe Sasri also is maybe working on it or promoting it, like apply only the water where needed. And you know which country is now number one in the implementation? And I did not see this coming. India. You know why? Because the fields are only half a hectare. And they have 3 sprinklers. So they have to decide where to put the sprinkler. And we have like a Vans Lab partner in India, and they make an app in Hindi. They get it every morning, and they can see then where they should move their sprinklers to. And it's working. It's working. And, we always think about high tech and center pivots with variable speeds, and then each nozzle, maybe different pressures and so on. And the Lindsays and all the other equipment providers are very hard thinking about it. And it's just implemented by Indian smallholders, So for me it means it makes sense. I mean, why are they doing it? Because it's making sense. You know? So somewhere of the concept is right. Okay. For the water groups, water agencies among you, if you really want to know how much water is used, so for California, we make monthly reports, like what is the total amount officially allocated since the start of the year, how much water have you been using, and you get a warning. You're like, hey, mister or madam, already 60% of your water is used. Watch out. And they have to pay a fee. They don't waive it. And the fee is steep. There are people paying more than $500,000 per year on fee because they're using more water than their entitlement. You know, so it's serious. But it's fair and it's transparent. Everyone now is moving in the same direction. So if you really want to have independent data for water user associations, you know, like you have this nice associations, you have your gatherings, but in the end you don't trust that other person always taking more water. Now it's solved. You can even make a very large screen on the street, you know, that everybody can see. Nobody can hide. And maybe some of you don't like this, you know. But believe me, in the end, this is much better for the sustainability, you know. So then we forecast the harvest. So this again is the dry matter production curves. I'm going back a few slides just to make the link. So, that's a lot of slides back. Actually, I was referring to this one. So if we are, let's say, halfway in the season and having knowledge from your milli from last year and before last year and so on, if you're already halfway, you can see whether you are in the upper end or lower end of the curve. We can start making predictions of your yield, assuming normal weather conditions, of course. Weather can always suddenly change and so on, but it helps, you know, if you have some better idea about how much is there. Then here is one for sugarcane. I was speaking about before that one of my clients, they really want to save on nitrogen for the simple reason that nitrogen prices are skyrocketing. Yeah, so they do not want to give more than a certain amount. Now, we express the nitrogen here as a percentage of the dry matter. You can also do that a kilogram per hectare. It's the same. You know, you can convert that because we have the total dry matter accumulation. And there are what they call reference curves. So there are reference curves for sugarcane, for potatoes, for corn. I have seen them also. Most crops, they have these curves. And that really helps whether you are under or below. Okay, I think that tells more than, okay, I have 130 kilogram of nitrogen being taken up by the crop. Okay, 130 kilo. So is that enough or not? You know, well, that depends where you are. Yeah, and actually what you see is towards the end, towards the harvest, that number can go down. That's no problem. And then also, this is a case of a grape grower. And he said, look, I want to know my nitrogen status for every block, for every, block, how you say? Block. Okay. And you can clearly see a big difference. So maybe it is on purpose, but I know in this case it was not on purpose. So he can improve on the fertilization plan. Okay. And already by doing that, he will gain a lot of money because the costs for area watch are much lower than for the nitrogen purchase. Okay, a few more. So here's just, unless my time is over, but can I still have 5 or 10 minutes? Yeah. So here is also a very nice integration of the AMI and then the temperature and then the production. So Roelof spoke about the electric magnet, the EM38, and that is there. What is on the lower left is also quite interesting. That is the production on the left-hand side in the green and yellow blue colors, and then the right-hand side is a classical soil survey, a gridded survey. Sorry, Roelof, I know that's very bad and very old-fashioned, but they just wanted to check whether fields with lower water holding capacity or field capacity, actually this is a field capacity map, had more production. Now, well, if you look closer, it comes out very nicely that all those cells, all the grids with lower field capacity had also lower yield. Okay, so it really makes sense. You can really, you can earn from having better soil knowledge. So you should voice your soil. Also, I added one more slide from Bare Soil in UK. I mentioned a couple of times that AreaWatch is measuring temperatures, but we do it the whole year round. So a data subscription is for 365 days. And you can start any day of the year. Usually that includes also a fallow period. But this is very interesting because this is fallow land, this bare soil in the UK. And even there I can see differences of 10 degrees. And you know what? When we had the final maps of potato yield, we could see back this map. So the hot temperatures in red are really the one with higher sand fraction, lower organic matter content, and so on. So this is a very nice way, really, and Leon and I will have some really discussions on this, on how to merge the EM information up to 1.5 meter with the 10 meter temperatures. It will be a nice addition. Okay, the insurance. So Bertus, here are your slides. So we are also working on what will be the certain risk that a certain temperature is exceeded, because certain insurances are based on amount of rainy days or very heavy rain days, or I know in Pakistan they look at number of days above 40 degrees. Okay, so you can do the risk assessment, how many days. Then you can look at the actual weather days, actual temperatures, and so on, which is good if you have weather-based insurances. But what is new is that we can also look at the water status. So on the basis of moisture or water balance, you can also pay out. So no longer it's just based on weather, but it's really based on water availability to crop. Okay. And finally, and that I think is superb, is that we can even look at crop production. I gave you examples that by measuring temperature and photosynthesis, we can look at the growth of crops. But then also we can have actual production, but also we can say, well, what is the impact of water? What is the impact of heat? And so on. So that is a completely new direction for insurances. Last piece, I think, also for sustainability reporting. So people want to know more about how much greenhouse gases, how much air temperature cooling occurs from irrigated crops, and so on. So this is more for the sustainability people. So to conclude, this is the slogan of VansLab, that you should voice the soil, and you should listen to the land. But I like to add here one more, and that is like you have to listen also to your pixels, because every pixel is talking. And with that, I would like to stop and see whether you have immediate questions or we have more time after the braai. Thank you.
All right. right, thanks, Wim. I just want to say, first of all, if he ever comes here again with a grid sampling example, that's the last time. Just before I get to the audience, I want to make one comment here that also one of our Western Cape clients, not the one you showed now, we went back to him after a while of using Iriwatch, and his comments on the accuracy of Iriwatch and the rainfall and just all the parameters that they measured was very good. So he was very impressed with the data that he got. Initially, he said him and his service provider, when they sat down and looked at the data, they said, but yeah, this can't be, what's going on here? And then they started going back and looking at the rainfall and what they had and they, okay, no, sorry, we won't question Iriwatch again. So even without the calibration that Wim mentioned now, that you guys can do yourselves, or we can help you with your own weather stations, Iriwatch is unbelievably accurate on its own. So any questions, any comments? Come on, guys, you can't let me fly him all the way here and then not ask questions.
Sorry, I'm going to make a few remarks, and I think Wim is probably too modest in terms of what he's presenting. I've been involved now, and I've got various guys coming to me and saying, but you have to help us selling our satellites or our drones and that kind of stuff. And then normally the question I ask them, but what is in it for the farmer? So if the farmer have to buy this data, what can they do? Will it add value? Can they, for instance, get a better rate at the bank for financing? Can they get insurance cover where they otherwise can't get? And I think this is, to me, the big advantage. What we did the past years, I already with Joseph tested that with another company, but Wim was with that company, it actually developed by him. We've tested Joseph's historic maize yields against the model. I've tested now with my daughter, she's in grade 7, for a science expo. We've actually used the irrigation farm in the Northern Cape for a 5-year period. And remember, this data, we can go back since 2017. You will have that on a 10 by 10 meter daily basis. You will have this information available. And we've actually compared, because one of the big issues in the Northern Cape is late frost on wheat. So we've actually tested the model, what the results will be. We've used 2 fields, and I've just sent them the information. I'm just waiting for the dryland here in Bloemfontein, also 2 fields. But our correlation was 91.5% between the actual harvested yield compared to the model. So I think what we see from this is, from an insurance perspective, even from a banking perspective, even from your grain traders perspective, it provides additional information about the actual yield. So it's not nice to have figures. This can have actually put value in your pocket. I had a discussion, I worked with APSA with Aaron Janowski, and we actually did a study at one stage, and we compare if you can get your finance a little bit earlier and you can use the current crop as security for the buying the inputs for next season, your discount, sometimes it's as much as what your financing cost will be for the next season. So I think there's various applications that we can use and that we really can put into market. We want to use that specifically from a product development perspective, looking at frost cover on wheat, where you use actual historic data. Because from an insurance perspective, what is your biggest issue? One of the biggest issues if you have to develop a product is you have to have reliable, independent data on the production. So you can't always use the data provided. So if you've got independent data, I can rate independently. So you can individually underwrite and you give a specific rate for a specific farmer. So I think there's various absolutely brilliant applications. For me, I'm a soil scientist. I work in the irrigation shelling also before. And one of the biggest issues, and I was in the Western Cape, also was in the Eastern Free State also, one of the biggest issues, where do you put your soil moisture probe as a reliable indicator of the irrigation shelling? So it's a big issue. This is brilliant, brilliant technology for me, specifically in that regard. So I think we do have something that we can use. We're definitely going to use that in terms of our product development on the insurance side. We can roll this out to the bank where they will have independent information. You can actually going back to 2001 and you can have independent data. That's on a wide, it's a 250 by 250 meter pixels, but you will have reliable data since 2001 of the actual yield of a specific field. So this to me is very, very good. And the other thing that Wim didn't mention that I think it's quite important, this is actually a virtual probe. I've read the article that was published by Wageningen, I think it's Wageningen University, where they compared soil moisture meters. And they compared the data for the different depths for the whole routing zone. And of that 10 that was evaluated, the IRIWatch from satellite imagery was actually the 4th best in terms of predicting what is the soil moisture in a routing zone. So it's really, really good data.
Yeah, so maybe to highlight that, so you're right, I did not maybe say that explicitly. So if we have the 10 by 10 meter, we calculate the moisture, and it's the moisture in the root zone. But it's really on the basis of that temperature from satellite. So that's why we call it a virtual moisture probe. There is no probe, but we can now measure the moisture every 10 meter by 10 meter every day. And people always are skeptical. So this was a comparison study with Wageningen University, and to their big surprises of the experts, we really were very accurate. And the accuracy, actually, the reference point was from Ovendry gravimetric soil moisture with bulk density measurements with the core. So exactly the same method that you use, because that is the most important way to measure soil moisture. So yeah, we can use that for crop production. I think I spoke about that. It can also be used for just irrigation, improving your irrigation or improving your nitrogen. What is the most appealing for you? What is the thing that triggers you the most? Like, hey, I can use it for this or that. Is there something that is jumping out, or is it too much overwhelming information?
Just on that. Hello. Okay. Just on that, the data that you showed now, the guy commented there that he's been using it now for 11 days, no? And it really looks very promising.
Okay.
So he's also very happy.
Yeah. That is an example of irrigation scheduling, which is good. And I know it's very hard to tell some of you that you can do better, because you all know that I know how to do it. I learned it from my dad, and there is a lot of experience. But if you have so many hectares, if you have hundreds or thousands of hectares, you need additional tools, on which pivot to switch on and when and how long and so on, And again, it saves you water and saves you energy costs. Energy cost is a huge thing. Even if you can save 20% on energy cost, already it pays back, the IRIWatch subscription.
Yeah, thanks, Wim. I think the other one, maybe on a dryland perspective, and what we want to do, and I've already had a discussion with you on that, is if we, for instance, can know on a dryland basis, remember one of the big issues is the earlier you can know what to expect, the better you can do your pricing and that kind of stuff. So it's not only a pricing issue. You can go to your bank and say, listen, but I know with certain amount of certainty, this is the crop that I will produce by the end of the season. But what we can do is looking at what is the dry matter production up to now. Historically, how does it compare historically to that specific field for that specific period? You do have the water content at that specific stage, because the moment the plant is actually growing, you know what is the soil moisture content. And if you overlay that with weather forecast, you can have a very good prediction of what to expect by the end of the season. Worst case scenario, best case scenario. So I think from a financing perspective, from a grain hedging perspective, hedging your grain and that kind of stuff, it's definitely something that will be of value.
Any questions? Wim, either you explained yourself very good or not at all.
No, but don't be shy. Just if you have a clarification you want to know, but speak to me after the braai. That is always much easier than in public.
Maybe after a few beers, guys, the tongues will loosen up as mine, so they'll ask questions then. Okay, if there's not going to be any questions further, you guys are more than welcome to get some cool drinks. Let's just take a 4 or 5 minute break. Get some cool drinks, stretch your legs. I know working with the profs, they like to give breaks because people tend to fall asleep when I see a few closed eyes. So jump up, stretch your legs, do some jumping jacks if you have to, and then we'll be back here in 5 minutes. All right, so this is the last formal part of the day. So Leon's going to speak, like I said, on the carbon credits. And then, like I said, during the lunch, please talk to them. And then afterwards, you guys are more than welcome. Then the floor is actually yours. Say what information you guys want, what do you expect, how we can assist. Okay, so Leon, thanks on the carbon credits. And then that's what the books are for. Make your notes, ask questions, guys, please.
This is now very important. I'm going to say I'm finished with the academic side of my equation, my life. 3 years, almost 3 years now retired. I should have retired much earlier if I look back. If I look back the past 35 years and all the great people, you will agree with me now. What you see in front of you when you're young will change. There's nothing in life that's fixed. It will change. Right, look at the politics. We thought the National Party will be there forever. It's gone. And the same going to be for the other parties. And coming back to our life, it was mentioned now the virtual probes. We thought that measuring soil water content in soil, I spent 35 years with it. And my students, Rian too. When you walk in a maize field with that CPN, and the maize is 2, 3, 4 meters high, and the wind is coming through it, you're getting mad in that field. So for me, when I met Prof. Wim, and he talked about virtual probes, and I said, what? This is really something new. This is novel, or they call it in science. Something totally new. And guys, you are sitting here and you are listening. If you want to be a leader in agriculture, that is our next 30 years, what's ahead of us. We're going to move away from soil water sensors to ERIWatch type of. I'm not saying ERIWatch will be here for the next 30 years, exactly, but there might be an improvement on ERIWatch in the next 30 years. A lot of improvement. Okay, so coming back now, my own speciality is soil physics, and I'm going to talk about organic matter. So there's a link between soil water, soil water, and organic matter. And organic matter is all physical properties, for those who don't know, because it's part of the solid phase of the soil. The more you've got in the soil, the better. All right, so that is the link. Water is always a link in semi-arid areas, like where we are. So understanding water and move then to organic matter, and organic matter coming from the crop. We are all in crops. All right, so there's it. That is the link. So today, I want to talk about carbon credits, the roadmap, how to sell it. I think that is something, oops, I just want to get this wind out of my nose. Sorry. Sorry for this. Right, so yeah, it's about the roadmap, how are we going to add value to our farming practices. Okay. So to understand what we're going to talk, think about the earth and what is happening above us. Okay, so 600 kilometers above us, that is the atmosphere. From that, outwards, you're in space. So this 600 kilometers of air, that's what we using day to day. Right. If you move now to agriculture, the biosphere, which consists of the lithosphere, which is actually the soil, the pedosphere, the soil, lithosphere, and the hydrosphere, and combined it forms then the biosphere. And why I'm saying this, because we're in agriculture, we work with these resources. Right? So, what is the problem then? One thing that we all share, doesn't matter where you are on the earth, at any moment, we share the same air. You see there, if you go back to that slide, you can see the earth is there and it's surrounded by the air around us. Right? So this is important. So all of us, doesn't matter where you farm or where you make your living, you contribute to the air positively or negatively. And that's why we can talk today about it. So what happened in the past? If you look at these graphs there, you will see from 1940 backwards, the increase was about 0.08 degrees Celsius per decade. And then it's another 40 years after the industrialization process started, where the CO2 went up and down. And from 1981, there's a constant increase of CO2 in the atmosphere. And you can see the rate there, almost 10 times more than in the past. So does it bother us or not? Is it important or not? So just to understand now, I'm going to explain this normally for my fourth year class, but I make it very soft for us today. I don't want to give a lecture. But Prof. Wim also talked about this now. The thermal properties of soils, the thermal properties of air. And some of my students published, hello, Bello, welcome. Published some of this work. So what happened? The question is, what happened with the beam of light that coming from the sun through to the earth on its path? So if you follow the first one there, I'm going to stand somewhere here. You can see only around 51% of that energy will end up at the earth. The question is, what happened from the 600 kilometers from there to there on the earth? So in this space here, in the atmosphere, there's matter. And we know the properties of matter. It can, any body, a body of a matter can absorb energy. If the temperature is above minus 273 degrees, it can actually also emit temperature. So that's a very important property. So in the atmosphere, there is clouds and a lot of other matter, gases. So these matter and clouds can also reflect that energy back into the atmosphere. And you can see the percentage there. Okay, so if you go now back to the pedosphere, and you can see now some of the energy that's been absorbed can also then be emitted to the atmosphere. And if you emit energy to the atmosphere, what's happening with the atmosphere? The temperature increases. And you heard about the stories over the news, 2 degrees Celsius. What a disaster the Earth can be waiting for us when that temperature rises to 2.5. Okay, so the reflection is there. The emission is there from the absorbed matter. And lastly, that is where irrigants also play a big role, is the amount of energy that's been lost through evapotranspiration and directly the sensible heat flux. So that is the link between us and irrigants, the temperature side. So I take it a little bit further now to what happened with the temperature inside the space. So the sectors, the different sectors that been listed there: energy, industry, buildings, transport, aviation, waste, forestry, and agriculture. All of these sectors contribute to the economy. We can't go without them. Okay, so if they're not there, this day will not be possible. Okay, so they do contribute, but we see them as a negative type of impact. I see them as a driver of the economy. Okay, so it's important. And we also are part of it, agriculture. We also emit CO2 to the atmosphere. So what is the impact if the temperature can rise too high on the Earth? So this is when I was in Durban a few months ago, 12 April, 1 to 12 April, on the eastern coast of South Africa, 400 people died in that flood in Durban area. 400 people. They say the other day to another 50, you can count another 50 with it in one storm. 40,000 displaced, families displaced, and we don't even know about it. 12,000 properties destroyed. That is you guys with your insurance. It's a nightmare. But more important, they expected that type of flood once in 40 years. Now it arises here in 1 in 20 years. You see the impact. We have to do something about it. Every one of us have to do something about it. All the impacts I listed them. I'm not going to go through every one of them. You hear them every day. I'll take this from an article in Nature. Nature is one of our top journals in science. So, extreme events, sea level rises and coastal floodings, snow and ice and sea ice, ecological impacts, damage to the sea and corals, outbreak of diseases. We heard about all these things. So it's not just there hanging, it is really happening due to global warming, due to the rise of the temperature, due to the rise of CO2 and methane, the greenhouse gases in the atmosphere. So this is the big contributors to the different countries. And we see that the Asian countries contribute huge to the CO2 in the atmosphere. Look at that pink there. Don't throw away America. Okay, there's always this fight in America. Then they're in this struggle to fight the CO2, and then they're out, and then they're in. I don't know where they're now. Maybe they're in to help to reduce CO2. Russia and South Africa. We're also in the top 20, 1%. Sitting here. The greenhouse gas emissions by sector, by large, you look at the numbers there. We talk about 14 billion tons where we are now through electricity. The fact that you put on your light in your home, that we contribute to CO2 in the world. Transport, we can't go out without transport. So every one of us actually contribute to this. And you can go through all the sectors there. The slides will be available afterwards if you want to study the numbers. Look at the electricity. South Africa now, yeah? The South Africans' data. Electricity and heat. We talk about just below 300 million tons of CO2 emitted through our systems. And still we go on with coal. Right? And the others are quite lower. If you look at fossil CO2 emissions, global territory, by fuel type, then you will see coal is by far, I'm going to look at this one. Coal is by far the highest. If you look at this graph here. Coal is by far the highest contributor to CO2 emissions, followed by oil, gas, cement. Oh, where's my cement people? So you can see always there. And interesting here, if you look at the CO2 emissions, gigatons of carbon per country, and China is around very close to 3 gigatons per year emitting, followed by USA, India down there. Now this is the interesting one, per capita. Look, per capita hours per person. So America uses about 4 tons per person CO2 emitted. You see there for that nice lifestyle that we all are used to. And if you look at India, because of the large amount of people, it's very low. Not to say it's, they're not there. We know the Asian countries are high contributor. Just a second. Okay, so what's the solutions? The first one is to create awareness. That's why we've got a day today, to create awareness about CO2. It's not a story anymore. I didn't believe it when I was at university. So I thought, no, I want more data. I think the data is not good enough. Now we see more and more people publish in Nature about this topic because it's so important. So create awareness, make sure that you contribute to less energy, less transport, use your bicycle. Now it's like that. Technology, we have to invest in better technology to reduce the emittance in the different sectors. And again, it's about people. People are managing that sector, so we have to create awareness into that. And carbon removal from the atmosphere. Technologies, but also the farmers. Now, that's why we are here today. We're going to talk more now about the farmers part. Plants are a very important mechanism to remove CO2 in the atmosphere. Actually, we need CO2, right? So my next part is what is a carbon credit and what's a carbon offset? And there's various definitions of it. And you can read it afterwards. But in short, it means 1 ton of soil organic carbon, not organic matter, organic carbon, equals 1 ton of CO2 emitter, or equivalent of 1 ton of CO2. Remember, methane, for example, have a capacity for heat 4 times more than CO2, for example. Just keep that in mind. So 1 ton of soil organic matter that you can store in your soil can actually also be 1 ton of CO2 removed from the atmosphere. And there is the equation that we need. So let's move to the carbon markets. There's 2 markets, the mandatory markets and the voluntary markets. I'm just going to stay with the mandatory markets for some while. So what is the mandatory markets? This is controlled by the governments right over the world. I think most of the countries, more than 160 countries, already committed to reduce CO2 at certain stages. So what happened now is the countries itself, through their governments, will cap industries, the different sectors that I talked about. So you're only allowed to emit that amount of CO2 in the atmosphere. So we started now to regulate this whole process. So there's 2 stages where a country can enter this. The initial stage, the INDC and NDC. So intended national determined contributions. So if you commit, you sign up with the Paris Agreement, and then you have to prove that you do it every 5 years. That's in short what happened with the countries. Oops. Sorry about that. So it's actually a good thing. So now what can happen is they will tax these sectors, different sectors. They will tax them and say you are only allowed to emit this amount. Above that, you're going to be taxed. Okay. So the other part of South Africa also agreed into this Copenhagen agreement, and we stated that we will join them, and that is our pledge for our CO2. For 2020 to 25, we will still increasing our amounts emitted, and after that it will reach a plateau, and after 2030, then we should go then down on our CO2s. It's a good thing. So this is our commitment from our government. Now the voluntary market, this is now organized by different companies, nothing to do with governments. On their own, they get together and they decided on their own that they want to contribute to a better environment, better air, better quality of air. And the last time I looked, 702 companies in this year already signed up the pledge. So now this is where the markets are. Doesn't matter what your government are saying, you can enter the markets from your farm. This is very important for us because politicians will always want to control everybody, put you in a box. Now the boxes are gone. Interesting, in the last few years, the two markets had merged into one. Still controlled by government, the emittance, and still organized by the private sector. They talk about cap and trade programs, emission trading systems. And if you look at the world now, you can see the different countries where they stand now in terms of the progress of that commitment, that pledge. And South Africa, you can see the carbon tax implemented or scheduled for implementation. So we're there from the government point of view. Look at where is New Zealand. New Zealand is probably the country that is the farthest on CO2 conservation. This is an interesting graph, and you can see the market's going to evolve here from this graph. It gives you the different sectors for the countries, where they stand at the moment. So the white areas that you see there, in that particular country, where is now, New Zealand. Look at New Zealand, it's down here. You can see all the color from the different sectors being occupied already there. But where you see white areas, that is where the market's still going to develop. So this is, we're starting now with carbon markets. It's only the beginning. For those who are interested in the economy of it, look at the price difference, how it changed over time. We talk about, oh, there's no data there. Eh? We talk about up to 100 euros per ton of CO2, yeah. But look where it starts, almost like 2 or 3 euros per hectare, moving up, and it's going down now. So it's typical market-driven enterprises now. New Zealand, look at New Zealand one, the same. So it's important to study the markets because you can actually get, now at the moment, you can actually get $2 to $3 and up to $60, $70 for a ton of carbon. So you have to study your markets. This is the potential for the business, for a farmer. There's guys that's starting here 2020, where we now 22, we're only touching now the total market of carbons, as I tried to show you in the previous. They talk about 2030 of a market between $50 billion and $30 billion. So it's a huge industry that's coming up. So for us now to be practical, in South Africa, we started with a company called Carbon Credit Market. This company will deal just with that part of the market, selling carbons. So in this company, we look at soils, plants, animals, and water as a starting point. And it concentrates on human capital. So that's your natural resources. And we will look at the different sectors: energy, transport, building, industries, aviation, waste, deforestation, agriculture. So we start basically with the farmers on the one side, with the carbon credits, and we're gonna put it on the market. This guys here on that side need to offsets. In other words, what happens now in practice, if a company are only allowed to emit a certain amount, and it go over that amount, the balance must then be buy on the markets as an offset. So there's an offset market developed on this side, and on this side there's the storage of carbon, and farmers can do that. So what is a roadmap for farmers now at the moment? So what we say is, you can register at CCM company. They're not ready yet. It's a new company. And you enroll with Eriwats. And we didn't talk about that now, and I haven't got a slide here. But in Eriwats, you can actually determine what is the CO2 contribution to your soil, what have you sequestrated in the soil, and what emits, and the net. Maybe, Wim, you can also talk about that, 1 or 2 sentences about that part of Eriwats. So we say, enroll for Eriwats, then we can monitor on a daily basis or a monthly basis how much carbon that you really sequestrated in the soil. So the first step, register at this company, then you enroll for in Eriwats. Once you've enrolled for Eriwats, there's conditions that will apply, that will be applied. And if Eriwats show you, we have to work backwards for a year or 2 or 3, it's multiple years. If Eriwats shows you a positive, that you actually conserve CO2, then we declare a positive sink. You're now a sink of CO2. And in other words, the asset. And then an independent site-specific verification process will start with SANAS approved. SANAS, you know SANAS, all the labs must, when you do analysis, must be approved by SANAS. And the aim is to determine and confirm scientifically the amount of carbon that you really stored. So although Eriwats tell you over this year there's that amount that's been stored, it's just the estimation. We still have to go out and do the hard work and confirm with soil sampling that the organic matter that is there is really there. You understand that? So that we call the verification process. So the lab is busy to do that verification process. Those guys who already scanned, I think it's like 20,000 hectares. They can immediately come into this because we scanned the area and we did the zoning of the area, permanent zones. So we can just go back and sample the organic matter. And we can do a calculation and a verification, basically, for your organic carbon. Okay, so once you know and confirm the organic carbon, then the next step is to put it on the markets. And that's what CCM is going to do for you. They will put it for you on the markets and get you the best price available. And lastly, then, once there's a buyer and a seller connected, it means then that amount of CO2 stored in the soil cannot be resold to anybody after that. That will be registered in the national registration process. And lastly, so once now you're using Eriwats and we verified it, that particular date when you verify it, onwards, you can just go on and do and remain with the cycle. So the first part is the big verification is to get that hard work is to get that permanent zones or management zones. And after the management zones, you can do your soil sampling And from there onwards, we monitor with ERIWatch. That's in short that we're going to propose for the farmers. It's 9 o'clock. Okay, before last part. So there is conditions. So we say minimum time is 1 year that you have to enroll for ERIWatch. And you can register multiple years if you want to. It's cheaper. And the minimum area is dryland is 100 hectares, irrigation is 25 hectares. And you can register any amount of hectares actually. So there's a summary. Just to state quickly, a few points then to summarize. We all share the same air. So it's for us important, it's beneficial for us to lower the CO2, every one of us. Put off the lights if it's not necessary. Make your small contribution. Don't drive in these big cars. Get a smaller car. It's simple things that we can do. Farmers, we can actually add value to your farm by registering your field, do the verification with, of the estimation with ERIWatch, do the verification, and you're in the markets and you get what we call passive income after that. If you are positive, in this case, CO2 positive. Thank you.
Thank you very much, Leon. But those big cars are so comfortable. So I don't want to go back to a nice little Datsun Go. Okay, you guys, any questions, remarks, comments? Bertus, I'll be with you now. Nothing. So I hope you guys see the link between the three of us that spoke today. It's coming in with the EM, the new technology in different, just to change your perspective of your soil management and optimizing your production unit, making sure that's optimal with ERIWatch and fine-tuning it, and then just by doing this and getting a more efficient system going on your farm, having extra or additional benefits with the whole carbon credit sequestration, it's an ugly word that, and the selling of those carbons. So like Wim said earlier, I think it's a big mind shift for a lot of farmers, and it's very strange. I thought when I started in the industry that you're going to struggle with the older guys, and the younger guys are going to accept the technology very quickly. And I must say that it's a very diverse, it's very strange. Some old guys, you get old toppies as old as Leon, what's it, 105 now? Eh? Yeah, 105, and they accept it like this. And then you get other guys, young, 25, 30, just out on their own, and then, no, my dad did it like this, I'm going to do it like this. So it's really a mind shift. And it's just not for not just certain parts of the industry, the whole industry, a mind shift and just accepting that new technology and going from here onwards. Like Leon said, in 30 years, nothing's going to be the same. So we must keep up with that change and make sure that we're on the front foot of that. And that's one of Vans Lab's main priorities, is make sure that we stay on that edge. And that's why Leon started this new company that he just spoke about. And that's why we took hands with ERIWatch as soon as we got introduced to them. We want to make sure that we are part of this change. We keep at the front foot of the industry and not just be followers. So hopefully the guys here today also saw that opportunity with our invite, seeing like, listen, yes, new technology, we need to stay on top of it. And hopefully I'll speak again to some of you guys afterwards and see how we can help you guys, assist you guys in going forward with this. Guys, if I look at the rusks and the juices and everything, please don't leave me with all that meat. I'm going to eat meat for 2.5 years. So please, everyone, dish up for yourselves. Let's have a nice steak, and then afterwards like I said, the formal part of today is over. We can have open discussion, nice open discussion. So any topic you guys want to discuss, let's misuse these two profs at our disposal. And me and Lindy, we're also available. All right. And then I just want to thank JP very much. I was hoping for a more interesting story about you and Leon. I know you guys have a lot of history. Like you said now, they're the old toppies. But JP, thank you very much for opening our day the right way. We just want to give you a little something from VansLab side.
Thank you.
Thank you very much. And then Wim, you as well, coming all this way. We're really going to enjoy having you with us this week. I look forward to it, and I really enjoyed your discussion this morning. Hopefully the other guys did as well. Just from VansLab side, thank you to say something to say. Thank you very much, and I hope when you go back to your hometown, you just have good stories to tell. Not say, hey, yes, that's South Africans. So I know he likes South Africa a lot, but it's actually his first time in Bloemfontein. So hopefully it made a good impression. If there's nothing else anyone wants to say, Lindy, you're done. I covered everything. Live link, guys. Thank you very much for joining in. I'm very sorry about the drop. We are going to upload the video on YouTube and connect the link. And we're also going to have the slides on the website as well. So for you guys, if you want to go and rewatch something or you missed something, just go to the website. And then you guys can also subscribe to our YouTube channel, where we will in the future have videos on sampling, whether it is your normal boeremonster like I talk about, or the core sampling that we do. So we do it on a commercial basis. We have our tools for that, but we'll be showing ways that you guys can do it for yourselves. Remember what we said, and as Bertus also highlighted, the importance of those core monsters, those bulk density undisturbed samples. We'll be showing videos on that, and then we'll have interactions or interesting videos going on our YouTube channel. And then we also had a radio ad show, or not a radio ad, sorry, a radio show this past 10 weeks where we covered a lot of different topics. That's also going to be on the website. You're more than welcome to go and listen to that. And it's also on Landbou Radio, agricultural radio. It's also on their website. So you're more welcome to go and look at that or have a listen. And I think that's that. What's the time now? Okay, I'm not gonna put a time on it. I'll just check as soon as everyone's almost done eating. We'll just gather again, and then we can take it from there. Live link audience, thank you very much. You guys have a nice day. Bye bye. And then the audience here, please don't take your stuff and run away now. Let's have some valuable conversations amongst each other. Thank you very much.